This is a normal distribution, and it can be used to study and represent a plethora of things, from heights to test scores to salaries to star cluster sizes. But before we get there, we need to slow down and start with the basics. Let's use a hypothetical scenario to explore normal distributions. Let's say you took the height of every male in your high school, plotted it on a bar graph, and got this. The mean height is 68 inches with a standard deviation of 2 inches. You probably noticed that most of the data is clustered around the mean, and the farther you get from the mean, the less data points there are. You also probably noticed that the data is symmetrical around the mean. These two factors suggest that this is a normally distributed bar graph. To better understand this concept, let's turn this bar graph into a density curve. This is still the same data, just a different format. If you were to take the area under the curve and above the x-axis, you would get an area of 1. If you take an area of half of this section, you would get an area of 0.5. This means that if you were to pick a kid at random from your high school, there's a 0.5 chance that they're shorter than 68 inches. Conversely, there's a 0.5 chance that they're taller than 68 inches. Now this is a pretty simple concept, but there are a couple of more complicated patterns that normal distributions follow. In normally distributed data, 68.2% of all data points fall within one standard deviation of the mean. Well, what does this mean in the context of our scenario? Well, one standard deviation below 68 is 66, and one standard deviation above 68 is 70. So, you can say that 68.2% of all males in your high school have a height that is between 66 and 70 inches. The area under this part of the curve is 0.682. Using this information, we can deduce that the area of this section is 0.318. If you were to divide that by half, you would get 0.159, which is the area of this section. This indicates that about 15.9% of males in your high school are shorter than 66 inches. In normally distributed data, about 95% of all data points will fall within 2 standard deviations of the mean, and almost all of them will fall within 3. Even though most data sets in real life won't be perfectly normally distributed, there's still an incredibly powerful tool that can be used to study and analyze many things in our universe.